I am live. Okay, so let me see. I'm gonna pause this so that I'm not streaming myself back to myself. I'll check on the stream conditions maybe from time to time. Okay, this is Toby, and I'm gonna continue with my quest to build a deep zoom debugger, deep zoom post-mortem debugger. Um, Last time we left off debugging this issue where after zooming in to a certain level, so we start off at the top level, and then if we zoom in, we get to the next level, and then if we zoom into another function call, we get to the next level yet, and so forth and so forth. But the problem was that if we zoomed in after a certain level, and in particular it starts happening here with, if I try to zoom into this FIP 5 and 4, we get this blank screen. So let's see that. Right now the computer is a bit slow. I suspect whenever my computer is slow, then the streaming isn't happening as well. Yeah, so now we have this blank screen, and we narrowed it down to last time. We narrowed it down to the fact that I actually have this drawing. The fact that it was trying, like, it was trying to fit this text within a box of around 114k pixels by 114k pixels, and it was something like, if you, there's a very small margin where if it tried to fit it in a 113k something by squared box, then it'll give me a font size. I'm sorry about the lawnmower, guys. I'm not sure what to do about it. We have a garden service coming in today to mow my lawn. I think I'm just gonna try my best to ignore it, honestly, because I don't want it to hinder my progress here. I really want to do this work here. Um, and okay, so anyway, so when I was trying to fit this text into a 113k by 113k box, then it would give me a font size of uh, 9 9,942 pixels font size, which means that uh, this is approximately a little less than 1/10 of this number, right? So, and since this number is so close to this number, I'll just sort of pretend this box represents the same thing. So each character is that much wide, and if it's about 1/10 of that, I segmented this out to 10 plus a little bit here. Each character is about that much wide, which does seem to make sense. Like, we have about 10 characters across the width of here. However, when we set the same thing for a 114k by 114k box, then it gave me that number instead, which is ludicrous. It gave me 38k pixels for the font size. Let me try to write good here. 38k pixels for the font size, which is approximately a third of 114k, which I wrote it out as about that big, and that seems wrong. So that was the lead that we got last time. Unfortunately, I had to cut that session short before getting to the root cause. But then since then, because I couldn't wait, I dug a little bit deeper than that. And what I found is that the reason this happened is because let's see. I did the good box and bad box thing, I think, in the last session, which looked like this. Whereas if we did the fit box on this good box, it'll give us that 9,000 something number. If we did it with this, which is the box is only slightly bigger, then it will get this 38,000 thing. And so I drill down to the fitbox algorithm, basically walking into the fitbox algorithm. And what I realized after some testing is that the measure text API is going bonkers. So let me show you what I mean. You know what? Let me just... Okay, see. All right. So if we ask measure text to measure the width of the character 1, which is just one character within the font. And it actually doesn't matter whether it's 1. I tried W because W is supposedly a fatter character than 1. I'll try W. Then it will give me 5,000. Even given this very ludicrously big font size. But if we gave it 9999 pixels, then it gives us, actually, you know what? I think it's best if I illustrate it with a for loop. So let's say let I equals to 1000. So 1000 font size. Actually, let's go 100. While I is less than, say, 300,000, we're gonna increment I by 100 each time. And then each time we'll say, we'll set the font size to I, and then we will we'll measure text, measure the width of the character W with that given font size with the font in Consolata. Actually, we should test other fonts other than in Consolata, just in case it's only specific to that font. It would be interesting if it were, but let's see. Okay. Oh, whoopsies. I need the uptick symbol in order to replace that I as a dynamic substitution. Okay, so, okay, and I need to do that here in the logging as well, because otherwise you can't tell which one is which. Okay, so this tells the story pretty well. So basically, if you say, given a font size of 100 pixels, let me bump this font size, the font size of the terminal a little bigger, so perhaps you can see better. So if we have a font size of 100 pixels, which the font size, by the way, is supposedly the height of the character. So if you had a character W, for example, which that's what we're measuring, the font, when I say a font size of 100 pixels, that means the height of the character is 100 pixels. When we're asking the canvas context to measure text, it's measuring the width of this guy, which I am actually surprised that this is 50, which is half of this. That I'm not sure if that's correct. That seems a little slightly dubious, honestly. I'm gonna try, although it could be that in the case of Inconsolata, because it's a fixed width font, it doesn't matter. Let me try. Yeah, I think that's why. So, but if you did Arial, yeah, let me do it. It'd be funny if for Arial the results are entirely different. Oh, for Arial we still have the same problem, which kind of makes me a little relieved. Okay, so for Arial, if you measure the width of W, it's actually it's just slightly smaller than the height, which I guess that's cool. So W, if I said this, the height was 100, then the width is 94.384, etc., etc., with some more decimals. So the width is slightly less than the height for the character W in the font of Arial. But if we did, let's say, the character I, let's see. For the character I, it's quite a bit thinner, see? For the character I in Arial, uh, in the font size of 100 pixels, then the width is actually only 22.2167 blah 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 pixels for the character I. However, because the code font that we decided to use is Inconsolata, which is one of my favorite monospaced fonts. It actually doesn't matter. All characters has the same width, and which happens to be half of the height of the character, which actually, honestly, is kind of surprising. But that does mean that I think that what that means is like there's like a lot of white space on top here, and then yeah, I think that's what it means. There's a whole bunch of white space on top of the character. In the case of monospace font, oh, this is I, so, but anyhow, I'm gonna try the capital W. Maybe the capital W. No, again, this is a fixed width font, so any character should have the same width, and that actually makes sense. But so you can see that in each case, the width of the character is half in this font. It's half of the height in every single case. Every single case, yeah. Until we hit 10,000. Once we hit 10,000, it's almost like the size of the font has been capped at 10,000. It can't go, so the measure text method will measure the text as if it was at 10,000, even if you go above 10,000. It's like there's an upper limit on the font size. And that is causing our problem. And our problem, namely, is that, let me see if I can articulate what our problem is. We have this fitbox algorithm that says, hey, I have this box, in this case, an enormous box, like 114K by 114K. Can you fit this text in for me? And the text is something like, you know, there's some code that we wanted to render. Fit 7 that this is the text we want to fit into this box. We're asking the fitbox algorithm to fit it in for us. It's gonna try to find the maximum possible font size. But the algorithm thinks that when it asks for a font size of 38,000, it actually, the measure text routine will actually respect that, but it doesn't. Which means when when the fitbox algorithm is asking, can you try 38K, then the measure text is actually going to measure the text at 10K, which I believe that means, oh yeah, so it's gonna fit. Oh, but the fitbox algorithm, it's gonna think it respected it, so it'll still count the height in terms of that number. So since this has 3 lines, this code has 3 lines, this actually is making a lot of sense. This code has 3 lines. If you measure the width, and the width of each character of was 38K, then it would have taken 3 characters to run out of space on the width, right? Because each character is like 38K. That's like about a third of this number, right? 38K, and even this, just the space might still take 38K. So this already ran out of space here. However, when we ask the measure text method, it's actually not respecting the 38K that we're trying to use, and instead it's measuring the width based on the number 10K, because the 10K is the max font size that measure text is willing to measure. So it's like, oh, okay, 10K, here's a character, 10K, 10K, space. Each one of these is 10K. Oh, I made that too small actually. So it's measuring the width in terms of 10K. Like this. Well, I'm running out of room a little, but it's not supposed to. So everything fit for because it was treating the measurement as the font size of 10K. But my algorithm actually took the font size and respected it because the font size is supposed to be the height of the character. So it's like, well, if the height of the character is 38K, that's gonna be take up this much. So 3 lines will actually sort of take up all of the space of this box, which is why it ended up at 38K. Okay, so that's the problem. I hope I explained that well. Now we need to find a solution to this problem. I don't know what the solution might be yet, so I'm actually gonna think out loud here. And so right now, the way that this system works, this zooming system works, is there's a world coordinate, and then there's a screen coordinate, and we have to translate between the two. And the zoom level, there's a zoom. The zoom level is like how much zoomed in the screen coordinate is relative to the world coordinate. So let's say the world coordinate was like this. So maybe this is the world. And maybe the world contained the box. Okay, so this is the world, and maybe the screen coordinate, the screen, and I believe the way I have it is the world coordinate initially is the same as the screen coordinate, which can make it slightly confusing. So let me double check the code. Let me check the stream condition. The stream condition is not that great currently. Okay, 27 frames per second. It's actually not too bad. Well, we'll do the best we can. Let me see. So I'm gonna look at the code and see what coordinate it starts with. It starts with okay, yeah. It starts with always the world coordinate is always the same as the 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 screen coordinate, which is start at 0, 0 on the top left, and then the canvas width and canvas height. So while this box might look like it's in screen coordinates, it's because it's based on dimensions of the canvas. This is actually the world coordinate. So that's kind of confusing. Might want to change that to be less confusing. Yeah, so let me. So the world coordinate is actually the world has a width and height of 1200 by 1200, and then the top left corner of the world, excuse me, is 0, 0. The screen coordinate is initially, excuse me, the screen coordinate is determined by what the current viewport is, which we have set it to this weird number here, but previously we had set it to this number. So we zoomed it out by zoom factor of 0.5, which is why the main box, we can sort of see the main box as like in the middle instead of covering the entire canvas. That was by design. I wanted to see the main box sort of as a box that's in the middle of the canvas. That's why we zoomed it out by 0.5, and then the top and left we sort of offset by half of the canvas height and half of the canvas width. So initial screen coordinate is something like this. Oh, no. We zoomed it out. So we zoomed it out to here. This is the initial screen coordinate. Yep, so this is initial. So because this is so we basically centered the world within the screen, so you can sort of see the world from a little bit farther away. And this coordinate here is going to be negative 600 by negative 600, I believe. Because it's negative half of the width and negative half of the height. So this is negative 600 by negative 600, and then because the zoom factor is 0.5, well, there's 600 here plus 1200 here plus 600 here is going to be, the width is going to be 2400, and the height is also going to be 2400. So the initial screen coordinate is going to be from negative 600, negative 600, and then width of 2400, height of 2400. This is what we're doing right now. The problem with this approach that we're encountering right now happens because if we zoom in, let me think. Oh yeah, let me think how the drawing actually works. Oh, let me explain how the drawing actually works. When we draw things, when we draw boxes, so when this guy says this is diagnostic code, that doesn't actually happen. But let's go to the render function to see how things actually happen. Yeah, so we're saying, hey, can you draw stuff? It actually converts the box world, the world coordinate to the canvas coordinate first. And so which means when it's saying, hey, I would like to render this world within this box, it'll say render the world within this box, and then it'll first convert these coordinates to the canvas coordinate first, which actually will mean that even though this screen coordinate this is getting really confusing actually. Even though this screen coordinate starts at negative 600 and negative 600, well, if we actually draw it on the canvas, this guy's correspond to 0, 0, because my actual canvas is, that's how actual canvas works. So my actual canvas has a width and height of whoopsies. Let me snap this picture. I think I can, like, copy drawings to clipboard is Command J. Command J. Did it do it? Command J. I'm not sure if it did it for me. I'm trying to copy it to the clipboard. I believe it also has a way to this can repeat. I think I'm going. Okay, that's all right. I'll just screenshot this guy. Oh, did I lose the drawing? Dang it, I might have lost the drawing, or either that or I've hidden it in some way. I'm not totally sure how to get it back. Although I think it has a feature of like saving screenshots though. Oh, because I clicked on this thing, it made it disappear. Ouch. Okay. Well, user error. That's all right. Okay. If I need to start over, then I'll start over. But okay. So 1200 here. So this 1200. So we're starting from so even though this guy gets mapped to -600 and -600 in the sort of screen coordinate, which is really confusing to call that screen coordinate now. Yeah, that's a really confusing way to do it. And in screen coordinate, the width and height are doubled. But when we say, hey, can you draw this thing into this box, it'll actually sort of translate this 0, 0 to this, well, to where this place ought to be, and to convert it into actual screen coordinate. So I think, oh god, even I have trouble keeping this straight in my head now. I want to try to explain what happens when you actually zoom in. Let's see. When you zoom in, this main box is gonna get bigger. Okay, so the box that represents the main function is gonna get bigger as you zoom in. So the screen coordinate, while it stays the same, so the world gets larger. So the world coordinate will be here. I think it might be easier if I just have the app calculate it for me and display it for me, instead of me trying to imagine it in my head, because I'm having trouble doing that right now. Okay. Let me see if I can get this guy to and maybe remove some of the logging. Alright, let me try this. Okay. So, yeah, so this is saying that the left and the top is 600. And then I guess I'll just, to tell you the zoom level as well, I'll call this update. I have this update log function. Width is ought to be canvas.width times viewport.zoom, and height is the same for canvas.height. Okay, so I've also displayed the width and height. Down here. That doesn't look right. I think maybe it ought to be divide. Yep, it ought to be divide. So as in sort of our viewport, maybe I should call it viewport instead of screen. Yeah. So this is the viewport. So here is the viewport. Oops, viewport. And the viewport is this guy. If we zoom in, what happens to the viewport? or the viewport gets smaller. You can see that. Let me just, you can see the width and the height get smaller. Yeah, the width and the height of the viewport gets smaller, which means that we have a viewport. We have a viewport that is getting smaller. Viewport relative to the world. The world is still like 100 and I mean not sorry. The world is still 1200 by 1200, and the right now the width and height of the viewport is less than that. So 1200 by 1200 maybe like something like this. Whereas this is 950 by 5 by 955, 957. By 957, the world is 1200 by 1200. So we're seeing a cropped version of the world right now. But the rendering of the text sort of dynamically changes to more levels of detail depending on how zoomed in the viewport is. That's how this stuff works. But I guess one of the problems is if you're really zoomed in, like let's make it really zoomed in. All right, we're gonna zoom into this level at which the viewport is quite small. It's 26, which is I guess 26 is like what? Is like a box like that. That small maybe? Maybe. So 26 by 20, maybe even smaller than that. Probably even smaller than that for sure. So the viewport is that small now. I'll call this VP prime to try to be mathy. 26 by 26. If the viewport is so small that it's 26 by 26, and the left, as in the top left corner of the viewport, is 886 by 146 relative to the world, whereas the world is 0, 0. Okay, so relative to the world, it's 886 by 147. Now, when we have to draw it though, when we have to draw anything within this viewport, we actually have to sort of convert the coordinates to the range between. First, we have to start at 0, 0, and then we have to convert it into the range between 0 to 1200 for the width and 0 to 1200 for the height. So this tiny box, 26 by 26 tiny box, gets scaled out to 0 to 1200 in both the width and height directions. But that means this dot here sort of gets scaled out to a very negative number, because if we're calling this guy 0, 0, then this guy will have to be a very negative big and negative big, two very big negative numbers. And that's where like we're scaling this very tiny box to a larger box. Therefore, the outer box that's much larger than this smaller box has to be humongous. And the way the layout algorithm works is it actually lays out everything starting at the top level of the world, and then it drills down to the smaller and finer elements, which are based on these function calls. So all of that is to say, we're end up with a very big box here, and this width and height will also be very big. And I'm gonna show you those numbers by doing some more sort of console.logs in or maybe not console.log, but it might be the display. So if I converted this box from the world coordinate to the canvas coordinate, and we displayed it in this same update log function. Okay. I'm gonna maybe like two fixed to each of these so that each of them will only have 2 decimal point digits, so it doesn't take up quite as much screen real estate. Okay, and then I'm gonna add in maybe I'll do like HTML in the inner HTML and make this so that I can use HTML here. Okay, and then I'll do a line 2, which is the box. Okay, so line 2 will be like world box, I'll say. It's gonna have a left of, or I'll say X. X of my box dot my box dot X to fixed to Y of my box dot Y to fixed with width of my box dot width dot to fixed and height my box dot height dot to fixed. Okay, I'll capitalize everything just because I have been doing that. Is that good? Okay, that might be good. Now computer is kind of slow right now. Oh, there's some ouch. There's some TypeScript errors, but my computer's kind of too slow for me to be able to diagnose the problems properly. Let me try to take away some of these console.logs so that it might be able to do things faster. Because if you have a lot of log output, it can slow down the execution of your code, especially if it's already slow. Okay, let me see. cannot find name Y. Where now? 408. Oh. Okay. Then close that curly bracket. All right. Okay. All right. So we have the world box. This is good, kind of. And it says that based on the current viewport. So this is basically saying based on this current zoom level and the top and the left of the viewport, I calculate the world's coordinate to be that. The world's coordinate is this box, by the way. The position of the world is this box, and it's at 300 by 300, and it's got a width of 600 and a height of 600 currently. But if I zoom in now, you know what, I don't care about this console output anymore. If I zoom in, at this point, we actually have the world, the size of the world is now based on the screen coordinate is actually it's been magnified to this. Okay, the world's position has been magnified to this. Yeah, based on our viewport. If we say our viewport is 1200 by 1200, right? So we sort of converted the coordinate of the world relative to the viewport, where the green part is the viewport, and the red part, this is we're saying is the world. So we scaling the world up relative to the viewport, basically, instead of the other way around. It could be that the other way around makes more sense, but I don't know. That could be. But this is how the code currently works. So if we zoom in even further, we can actually see that the width and the height of the world gets increasingly larger as we zoom in, because our viewport is within this very small slice of the world. Like it's basically like we're looking at this little very tiny part of the world, and then the world is that, and then we're saying, well, but the viewport should be scaled to 1200 by 1200. So we're going to scale the coordinate, the height and the width of the world relative that to this 1200 by 1200. So that's how we get a very enormous size for the world. It's all been scaled up relative to the viewport. Whew. So, and also this is this x and y of the beginning of the world. This 0 has been scaled to a very large negative number, right? And because the layout algorithm then takes this very large box and tries to fit text within it, then that's what caused our measure text threshold, font size threshold problem. That's why we met that problem in the first place. So now, let's talk about what we can do to fix this problem. So one idea is to, I guess the reason we chose to do, or maybe, I mean, don't start from a different direction. Our fitbox algorithm is based on the idea that we want to we want to maximize the use of real estate on the screen and be able to display very crisp text. Okay, so this font this this text is rendered at maximum resolution uh, for like it's not been scaled up or anything. This font size is very crisp. Um, is is rendered directly to this canvas, and in order to have the crisp display of the font, we sort of don't want to do any scaling up of images. Um, which is what the Fitbox algorithm does for you. It will find the largest font size to fill up that space. Okay, instead of rendering at a lower font size and then maybe like scaling up the image, that's not what we want to do. We want to use the optimal font size. Um, and that in order for that guy to work, we actually need the Fitbox algorithm to do its calculations in the real screen coordinate, which means if we're gonna have a let me see if we're gonna have this situation where the viewport is looking at a very small subsection of the world, like so, but this very small subsection of the world, if you actually looked at the details, it has very fine details in it, such as I don't know, it's got code in it, it's got diagrams in it, etc. So the user is actually looking at very fine details. We want those fine details to be rendered in a very crisp way. And so when we're saying, hey, this stuff here, this text that we want to fit into this box, fit box. Come on, Toby, handwriting. Right, good. So we want to fit this text into this box. We actually want to, and fit box ticks a bounding box with a width and height as one of its parameters. We actually want to use the screen coordinates for fitbox. We want fitbox to be operating on actual screen coordinates. But currently, we're also using Fitbox to lay out this entire box, and that's where the problem is. So what I'm thinking actually, so we're using Fitbox to also lay out like the outer box, which has stuff like maybe the top level looks like this. Oopsies. Okay, so the top level has stuff like this, but we zoomed so far out that we're at like the fourth level of fib, maybe, right? Like this is looking at here, which is like very deep into the Fibonacci algorithm because we zoom into this guy. We're currently using Fitbox to lay out this text at a very large size, and that's what I'm thinking maybe we should stop doing, because this text is not getting displayed on the screen anyway, because we're actually like zoomed into a very small slice within here, so we're not actually even looking at this stuff. Maybe we should stop using Fitbox to lay out the parent or the outer boxes. Instead, only use Fitbox to lay out the stuff within the inner box where the stuff is actually on screen. That's what I'm thinking, and how to exactly achieve that, I'm not 100% sure that. sure about that. But I'm gonna take a short break, short bathroom break, and I'll be right back. I am back. All right, let's do this. Um, okay, so one thought I had over the weekend is that uh, in order to avoid calling fitbox on the outer boxes and to allow calling fitbox only on the portion of the scene graph, if you will, that are within the viewport, what we might be able to do is sort of take the layout calculation from the previous iteration, um, find the box, like find the box that's within the viewport, or perhaps find um, smallest the smallest box which uh, which accounts for all of the viewport. So what do I mean by that? Um, let me see. Okay. Um, so let's see. So let's come up with well, we'll just use this example, right? Um, so in this example, we have this fib7 box. We're gonna zoom into it, but currently it should not be like seen as the primary as a primary box that houses all of the viewport, because it doesn't house all of the viewport. Currently, we have to use the outer box, the main box. So we have in this program, I guess we have the main function call, which within the main function call we have a fib7 function call. And then within the fib7 function call, we have probably a few different calls to fib. So within the fib7, we have fib6 and also fib5. And then within each of those, there's more, etc. But if we are zoomed in to say right now we're zoomed into fib7, I believe. Though we do see this outside code. Fib7 is not totally covering all of the screen, but at this point it is. So at this point, all of the viewable parts of the screen are within fib7. We're probably here or something ish, right? Um, if we have a situation like that where the viewport is entirely contained within a sub-box of the tree, then instead of having to call fitbox on the outer box, we're gonna not do that anymore. We're gonna short circuit and only call fitbox on the inner box. I think that can work. I guess there's another idea which which involves sort of I guess another sort of question that's bugging me about this is that whether or not we should scale things up like that, like scale things up based on what the viewport is. Based on what the viewport is, scale up the size of the world just for our purposes. But I guess we kind of have to do it that way because we have to satisfy what Fitbox needs. Okay. So I feel I'm comfortable enough that I want to give this a try. So we kind of need to, first of all, let me go find. We first of all we kind of need to break out the different parts of Fitbox. I think currently we have a one Fitbox function. One Fitbox function that first finds the layout and then renders the box. I think we may need to do them separately now. So what I'm going to do is have Fitbox not render just yet. Okay, I'm gonna have it not render, and then when you actually mean to render the result of the Fitbox, you're gonna actually have to call render yourself. So Fitbox is gonna give you a bbox map, and then if you want to render, you have to call render. Oh, this is quite confusing. I'm gonna call this text box, extract this out. So I'm gonna render the text box, give it the bbox map, and also the canvas context to tell it to render. I also need to import the render function now from the Fitbox library. That was the first call to Fitbox. There's a second call to Fitbox, I think, over here. And same thing, I'll need to call render separately after Fitbox is called now. like so. So this should do what it had done before. This is merely a refactoring. Where did my Atom editor go? Wait a minute. Oh, there's the Atom editor. Okay. Let me check. Is the audio streaming quality still good? It's actually currently okay. It says excellent, but who knows? Okay. I think there might be a problem, as in the text is not rendering now. Let me see. Oh, I have some compilation errors, so go fix those. Oh, okay. TypeScript wants me to, I have to appease the TypeScript. So let me call this a text box. And I think it might be, yeah, let me look at this window for compilation errors. Instead of the browser window, I think that will help me because I get the feedback a little faster that way. Expected 0 arguments, but got 3. Oh, shoot. There are 2 render functions. There's the render fitbox. There's the render function in fitbox, and then there's render function inside this index.tx. So I'm gonna do as render fb, standing for render fitbox. Yeah, let's do it like that. Okay, render fitbox here, and we'll do render fitbox here as well. Okay, let's see if that works. You get that compiled at least. Okay, this is working again. Great. I'm happy. Actually gonna remove these console.logs because they are just slightly bothering me. Okay, they are these ones. This code is messy with a lot of commented out console.logs right now, but you know, we are in workshop mode right now. Sometimes you have to get the workshop dirty before you clean it up. The dust is flying everywhere right now. Okay, so we're zooming in. Okay, but this should work just as before. Nothing has changed. All I did was sort of yank out the render to a separate separate call that the user of the fitbox library has to call this guy manually now. The reason to do that is we may we want to get access to this VBox map, which actually is, excuse excuse me, I have a little bit of a cold right now. Okay, so we actually did have access to this, so maybe I didn't totally have to separate that out to get this, but we need this VBox map to um, to go through the B boxes. When I say B boxes, I mean bounding boxes, by the way. If you haven't been following the previous episodes, you may not have realized that. Okay, when I say B boxes, bounding boxes. So the bounding box maps each text element or a container of a text element to a bounding box on the canvas. And so right now what I'm thinking is I can loop through all of those bounding boxes and find the smallest bounding box. The smallest bounding box which entirely contains the viewport. If I can do that, oh, I love this rainbow colored rendering. If I can find the smallest bounding box out of all the sort of text elements or containers that entirely contains the viewport, then I guess the smallest bounding box, which is a function call, which represents a function call actually, because not necessarily all bounding boxes. Is that right? Because let me think. Yeah, it'll make this algorithm easier. So we have code that looks like this. Um, so this guy is the important one. That guy is if the viewport is entirely contained within that, then I'm gonna use that as the main. What should I call this? Main. Oh, maybe I should call this the subworld. Subworld. And I'll call fitbox just for this instead of having to call fitbox for the outer world. So maybe the word world in subworld, or maybe region and subregion, region, subregion. I don't know if I like the word region. The word region is quite overloaded. Scope, maybe? Scope. Okay, maybe like this is a scope. Main, the call to the main function is one scope. There's the main scope, and then there's the fib7 scope, and then within the fib7 scope, there's the fib6 scope. Within the fib7 scope, there's also the fib5 scope. But within the fib6 scope, there's a fib5 and a fib4 scope too, etc., etc. So maybe I call this the scope. So the I'll have a special scope that is the current rendering, current the on-screen scope, the current on-screen scope. Maybe the current, or maybe just current scope. Yeah, let's go with current scope. So I want to find a current scope, which is defined by the smallest bounding box, which entirely contains the viewport. The smallest bounding box corresponding to a function expression, or not function expression, function call expression, which entirely contains the viewport. So a function call expression being something like fib of 7, or this is a function call expression, this is a function call expression, etc. So the smallest bounding box corresponding to a function call expression which entirely contains the viewport. If I can find this guy. If I can find this guy, I'm gonna say that is the current scope, and then I can only call back on the current scope. Yeah, unless if we unless we find that the current scope, the bounding box for the current the bounding box for the current scope is whenever we zoom out again, we sort of have to move the current scope back up to its parent. So that's something we have to consider as well. But for now, let's work on just this part. Yeah, let's just work on this part. So how do we do that? Don't worry about this one. I'm gonna worry about this one. At some point, I must have known about all the function call expressions. So this, I have not handled this yet, but currently I have this dictionary, I think. I have this dictionary that is, where is it? This splits the line if it's got a function call on it into 3 boxes. This is some debug code I've put in, which I don't need anymore because I figured out what the problem was. And then, oh, nest execution. Where is nest execution defined? Here. Okay. So nest execution contains, it's a dictionary that is keyed by the line number, but it gives you a history, an array of history entries. I see. So this is like on that line number you call the function, and then the function call, the this assumes, let me just make a comment, assumes that one line can only contain one function call currently, which is not a good assumption in general, but we made that assumption to make things easier for us. But we can fix that later. So the history entries with that are accessed by this line number will be the execution of the function call that was made. I guess the question is, how do I know if a box represents a function call? If one of these text box, it will be this second chunk. The second chunk oh, I have this call expressions boxes array that remembers. Okay, this is kind of a hack. So this is call expressions or call express boxes is a array that remembers all the text box and it actually associates the call expression, which is in AST node here. Let me see the definition of this guy. Okay, so let me write out the type definition of expr. This is an AST node. Can I even write comments like that? Yeah, I can. That's an AST node, and then there's a box, which is a text box, I believe. I think so. Yeah. It's an array of these things. Yeah. Does it compile? Yeah, it does compile. So basically you can loop through these boxes. Yeah, I think that works. I'm gonna loop through these boxes, and then because I have this text box thing, which can be mapped to a bounding box using the bbox map that the fitbox algorithm gave us. So I'm gonna do that. So after calling the fitbox algorithm, I have this bbox map. Now I can go for loop to get at the we'll get the box first, which is a text box. And then I can get the bbox from the text box via looking up the bbox map. There. And now with this bbox, I can try to test, hey, does this bbox entirely contain the viewport? Yeah. So, and the viewport is always static. The viewport is always gonna be 1200, 1200, and then this is 00. That's always the viewport. So if I get a bounding box, I can just, first of all, I can say, is it x and y equal to or greater than 00? And then also, yeah, let me do that first. Contains viewport is equal to if bbox.x is greater than or equal to 0 and bbox.y is greater than or equal to 0. Also, I need it if I so let's say the bounding box was over here. Wait, that's not right. No, I want the reverse of that. I want to see if the bounding box entirely contains the viewport. So it should actually be less than or equal to 0 and less than or equal to y. Should be the reverse of that. And then I want to know if I subtracted the width of the viewport from u, so I just subtract that from u, plus let me see. Is it still greater than 0? Yeah, it's subtract. You take your width minus 1200. Is it still greater than 0? I think that's what it needs to be. Width minus 1200 is greater or equal to 0, and then same thing with the height. Okay, so is contains viewport. It's fine. So if contains viewport, then I'm gonna say found new current scope, and I'm gonna print out what it thinks that is. I think I'm just gonna print this whole guy out, and also the B box. Right, see if that works. Did I mean B box? Yes, I did mean B box. Let's see this. So I'm gonna zoom in more. If I zoom into the level of, we're only looking at fib7, then that should kick in. We're not there yet because this part here is still not part of fib7, but if we do, yes! Now we've found a new current scope, which is, yeah, fib7. fib7 is the new current scope, and this was its bounding box. And you can see that this entirely contains the viewport because the x and y is negative. It contains 0, 0, and then the height is tall enough despite this offset to contain all 100 and 200 pixels, and the width is also wide enough to contain all of that despite this offset. And then if we zoom in even more, let's see, to here, okay, it still says fib7 right now. Okay. Yeah, we're entirely in fib7 right now. Okay. If I zoom out, then we don't have. So maybe what I do is like, let me think. I'm gonna like remember like have an alter variable store this information like this. I guess I'll do if we found it, basically. We'll print it, else no subcurrent scope found. Also, if found subcurrent scope, as in it's a smaller current scope. I can't print out the B box here for some reason, unless I do need this at some point. So I will save it in here, and then perhaps once we found one, there's a possibility that we find multiple, maybe. Although I actually think that's not possible. That might not be possible. I'm just gonna break out of this loop and then see. let me see. So no subcurrent scopes found until a zoom in more, and now we found it. Now it says, it's saying again. Whoa. Oh, okay. Oh, okay. Let's see. Because we're still seeing something from the elder scope, which is this very big bracket here. So I actually need to zoom in a little bit more. So now but if we pan a little bit to the point of being able to see something outside of the FIP7, then there's no subscope currently found. Although they kind of alternate, which is kind of weird. Yeah, they kind of alternate. I think that means different printout is given for a different recursive call. And so it might be possible that we actually want a property of this whole render function, this entire render function, to return the one current scope, actually. As in, if we can find, currently does it return anything? No. That's great, because we can make it return stuff now. Okay. So my plan is to make it return like the current scope, whatever type that it may need a bounding box. It may need the call expression as well. It may need all the information we have found for the what we are calling the current scope. If we're able to do that, then whoever is calling this render frame entries, which is the entry point of the render function, it can receive the current scope here, maybe like that, and once it receives the current scope, maybe this is a global variable or like a state variable that persists on, and then the next round instead of calling this guy with this all of the history, it can only call it with a sub-slice of the history. Yeah, which can be derived from the current scope. Okay. So that's the plan. I think I'm gonna go get some lunch, and I do plan to continue working on this afternoon.